Okay, so today we're going to talk about how to solve double displacement questions. So the first step you got to know is both of these are aqueous. The reactants are always aqueous, even if it doesn't tell you. It just always is. And then, now we're going to have to identify the metals and nonmetals. So, I'm going to use orange for metals and purple for nonmetals. So, sodium is a metal. And then, iron is a metal. Hydroxide is not a metal. And chloride is not a metal. Okay. Now, we are going to switch each metal and non-metal together. So what that's going to look like is we're going to have sodium and chlorine together, and hydroxide and iron together. So Na, Cl, plus Fe. Oh wait, so the second step here is, since we identified and figured out which goes with which, we're going to have to make sure each of them are balanced with each other. So what that means is we're going to look at each individual oxidation number, and we're going to make sure they go together and they equal each other. So sodium's a +1, chlorine's a +1, so we're good on that one. This is a +3, and this is a +1, -1, I'm sorry, -1. So what we're going to do is to get this to be a -3, because we need it to, this is a -1 too. But to get this to be a -3, because this has to equal 0 for this to be a true statement. So to get this to be -3, because we want 3 minus 3 equals 0, right? We got to put a parenthesis around this one and put a 3. The only reason you put a parenthesis if it is a polyatomic ion, and it'll tell you if it's a polyatomic ion on your sheet. Now for example, if this was just to say a +2, right? This would be a 2. Now, this is a +1, of course, but I'm just giving an example if it wasn't a polyatomic ion. So now we have everything balanced and ready to go. We are going to make sure the elements on this side are the same. Elements and polyatomic ions in this case, and they're the same on this side. So we have NaOH, Fe, Cl. So you have 1, 8, 1, 1, 1, 1, 1, 3. Okay? This one we have 1. You have 3 OHs. I like to put them next to each other so you have a better idea. You don't get screwed up. You have 1 Fe, 1 iron, and you have 1 chlorine. Okay, so right here we can tell there's a difference. So we have a difference with hydroxide, and we have a difference with chlorine. Okay. To make this equal to each other, we have to insert a number in front of each equation. You can't just put a number down here like we did before, because to get to this point where we can balance them, we have to balance each individual one to make the statement true. So once you made that statement true like we did in the previous step, we got to balance everything now. So we're going to look at hydroxide. We have 3 on this side. We only have 1 on that side. So we're going to put a 3 here. And that changes this to a 3 as well. 3. Right? On this side, we only have 1 chlorine. Now we put a 3 to make this a true statement. And this changes sodium to a 3 as well. Now you notice each one equals each other. Yay, right? Well, we're almost done. Now we have to identify what is aqueous and what is not. Now, I'm not 100% sure if you do that in physical science, but I see the aqueous in some of your homework problems, so I'll do it just to teach you. So we got to look at our sheet. So our sheet tells us we gotta know the difference between soluble and insoluble. They're labeled soluble and insoluble. Insoluble is aqueous. And soluble is a solid. Okay? Think of solid as solid, okay? And so this will be AQ and this will be S, right? Okay. Now we're going to look, and we're going to look at the chlorides. So on your sheet, it should say insoluble. We're going to look for chloride. So it's on the soluble side. Chlorides, bromines, and iodides except silver, lead, and mercury. So if we look at that, that is aqueous. Because if we look at this one, that is not except sodium. Let's see, we got here. Yeah, we have only the exceptions are silver, lead, and mercury. So this would be aqueous. Sorry. On your sheet, you'll see what I'm talking about. It has like two sides. It says insoluble, insoluble. She'll give you one, and it's like this. I think actually, it's soluble and insoluble, and it says, you know, chlorines except this one and whatever. But anyways, so this is aqueous. And now we gotta look at hydroxide. Hydroxide is insoluble except for group 1, which iron's not. Strontium, barium, and ammonium. And iron's none of those, so that's solid. And so that is our final question. That's our final answer. I'll do one more just to help you. This time I'll make it a little easier. I just wanted to see what you guys are doing. Get you prepared, you know. It's better to be prepared than not. So, next thing we're going to do is, I'll do one that we don't really have to balance that much. How about, let's do this one. Na2, CO3, plus CuCO4, SO4, I'm sorry. Okay? We're going to look at this. So they're both aqueous because we know everything on the reactant side is aqueous. Right? Both aqueous. Okay. So now we're going to identify what is the metal and non-metal. Grab different color markers or something. Help you out. This is a metal. This is a metal. Non-metal and non-metal are right here. Right? Next step is we're going to switch them around. Take this orange one, maybe do this purple because we have a metal and non-metal here. And we switch them around. We have metal and non-metal here, so we switch them around. So we have, let's see, we have CuCO3 plus NaSO4. Now we gotta identify the charges. So that's sulfate, and sulfate is -2. And sodium is a +1. That's not correct, right? Because we gotta get this to equal 0. We wanna make this a 2. So we're just gonna put a 2 here. This changes to +2. And 2 minus 2 equals 0. We have copper. And we have carbonate. Copper is a funny element because it has multiple charges. So you have to look at this element where it combines with to identify its charge. So we're going to figure out sulfate. So sulfate is a -2, right? Copper has a +2 or a +3. If this is a -2, this has to be a +3, a +2, because it has to equal 0. So this is going to be +2. Carbonate is, let's find it, -2. That equals 0. 2 minus 2 equals 0. We're good. Everything's balanced, right? Now we got to identify, we got to make sure there's the same amount of elements now are on each side. So we got NaCO3, Cu, and SO4. So we have 2 NAs, we have 1 CO3, we have 1 Cu, we have 1 SO4. Next step, you look at Na. We have 2 of them here. CO3, you have 1 here. Cu here, we have 1. And SO4, we have 1. In this case, we don't have to balance anything because they're equal to each other. Right? Next step is we got to find out what's going to be aqueous and what's not going to be aqueous. So we're going to look at carbonate on the sheet. Carbonate's insoluble except group 1A and ammonium. So that should be aqueous. That should be aqueous. Move the plus right here. Should be aqueous. Because insoluble equals AQ, aqueous. Insoluble equals a solid. Okay? Now we have sulfate. Sulfate's a -2. Right? -2 charge. Sorry, going backtrack. Sometimes I get a little ahead of myself. So we're going to look at sulfate now. So sulfate is sulfate's soluble except calcium, strontium, barium, mercurium, lead, and silver. That is sodium. None of that is on the list, so that's going to be solid. So this is your final answer. If you have any more questions about this, shoot me a text or something. Maybe we can do this over tutoring, but this should cover you for a while, at least till next week. The basic ideas are, I'm just going to erase this, so maybe in words it'll make even more sense. I'll write this down. In a word sense, you want to identify metals and nonmetals. And then you also want to be able to, switch the metals and nonmetals together. From other sides. If you're confused on that, on the few problems that we did, the ones I underlined, you're just going to take it to the other side. Third, you're going to balance each. I'm going to call it, I don't know what the technical term is, I'm just going to call it sub-equation. So you're going to balance each plus thing together with oxidation numbers. And then the fourth step is you're going to balance them, which is you're going to balance everything to make sure they're the same. And then the fifth step is you're going to determine what is aqueous and insoluble, or insoluble. Which is, that's not how you spell aqueous. That is insoluble. Soluble means that it can form a solid, and aqueous is water, or a liquid. Not all aqueous things will be water, but in this case we're just going to call it water. And or determine if they're aqueous or a solid, which is solids. That's soluble. And that's just a solid. And then after that, you're done. Just check your answers to make sure they're right. an easy way to do that is just determine the oxidation number first. And then you're going to balance them. Balance the whole thing. Thank you for watching. I'll see you later.